All right, so Portfolio Optimizer. Oh, I just deleted a bunch of stuff that we talked about before. Anyway, Solver. Hope you know about Solver. We're just going to optimize it. We're just going to automate it. So download Portfolio Optimizer start.xlsm and go ahead and get it open in Excel. So the idea here is that we have a set of tickers that we're going to put into a portfolio, and we would like to minimize the risk subject to some constraint about what our expected return is. So we've got some data here, and I'll just kind of walk through the model. The whole idea behind Solver is that you've got a series of equations, a series of formulas that are interacting with each other. You've got some inputs that you're allowed to plug in, and you want Solver play with those inputs to do the best that it can to maximize something or to minimize something or to try to get something to a particular value. So what we have here on the Consolidate tab, these are monthly returns. This is the average monthly return. So we're going to look, or this is the monthly return. So in whatever month this is, what were the dates we had selected here? So this is from 2007 to 2013. It's an interesting time frame. I'm not sure I would want to be making my decisions based on what happened in 2008 here, because that was a different world. But anyway, that's where these data are coming from. Yeah, if we could go back. Bye. So what this says is that in that first month, ExxonMobil lost 4%. Its stock price was down 4% in that month. The next month, it was up 0.6%. Is that what that says? And so the numbers that we have here is this. In that month, how did it perform? So what would I expect to see if something if a stock was more risky? What would I expect to see by looking at this? Yeah, lots of up and down. If something's kind of steadily going up or has a little bit less range here. So having these numbers here is going to allow us to have some sense of how risky these stocks are. What else can I tell from this? If I look at the average, right down here, then that tells me that's the average monthly performance of this stock. On average, this stock has been going up 0.5% per month. It's kind of a strange average to think because it's got 2008 in the middle. So we've got 2008 all the way through the recovery, 2013. But that's the numbers that we're working with, and we're stuck with that because Yahoo has changed the interface that they use to provide historic data that this workbook expected. Okay. So then here's just a summary. We see the means of each of these stocks, standard deviation, which will give us a sense of the risk. Will give us a sense of the volatility, rather, not the risk, but the volatility. How big the number, what the distribution is of the numbers. So I could have all positive numbers, but they could still be widely varying. I could have a high standard deviation and still think, hey, this is a pretty safe stock, and so it's going up. But now, what I have here is I have correlations. So we're looking here, the correlations between each of the two stocks and their average monthly return. So what does the correlations help me do?
Diversify.
Yeah, it's going to help me diversify. Because if I have two stocks that work together most of the time, let's see, here's a correlation of 0.5. That's a pretty high correlation. There's a higher one, 0.6. Is there a higher one out there? There's 0.7. Where's 0.7? Ford. Where's Ford? And ASP. Oh, right here. Yeah, that's really highly correlated. And so if I have Ford and I add in my portfolio, I add American Express, that doesn't give you a lot of diversification. So you kind of see how the basis of how we can be figuring out what's our diversification. Okay, so let's look at the model. So the way this model works is it says, listen, you go ahead and plug in however you want to play with the weights right here. So your means are right here, your average monthly return right here. As long as whatever weights you put in here sum to 1, you fully distributed your funds across the portfolio. So it looks like American Express. Why would we load everything into Apple? Why would we load everything to Apple? Is that our highest performing stock? Yeah. So that was just to show, if we load everything into here, our expected return of the portfolio. Let's see. There's a expected return, right here. Here's the expected return, or the required return up here. And it is, exactly the same as that particular one. But we want to diversify. So let's just go ahead and equally diversify. I'm going to put in 0.1 on each one of these. I think we have 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we are equally put out there. So now our expected return now is 1%. If we have a required return of 2%, this isn't going to get it for us, right? So we have to play with this, and that's what we're going to do. We're going to give ourselves an expected return. In fact, maybe I'll give myself an expected return of 0.015. So that's a 1.5 monthly return on this portfolio. The question is, so right now we're not quite there. We're at 0.011. So what would we have to do to get up to this? Yeah, get some more apple, right? Get some more stocks here that are performing above that number, and so we can do it. So let's find a low performer here. Who's our lowest performer? ExxonMobil. You just got zeroed out. You're dropping out, and we're going to double Apple. And we'll come back there. That's pretty low. I will change this one to 0.2. Almost there. You can do a little bit more. Okay, so we can do that. But while we're doing this, it's not just a matter of getting to the return that we want. We want to do that in such a way that our portfolio standard deviation is as low as possible. We want to get as the least amount of variability and still be able to get up to this number. All we're allowed to change is this, and it's subject to some constraints. So let's first go ahead and do that with Solver and see how it works. So I'm going to come to the data tab. So are we kind of clear on the model so far? How many of you are going, this model is mystical to me? So it's kind of mystical to me, so I'm glad that you're with us. So I'm going to choose data. I'm going to come to Solver. And is there a clear here? Because I'd like to kind of start, let me just reset all. Okay, reset everything. Sure. So now we're starting, I hit reset all over here, so we're starting with a blank model. So the objective cell is, what is that cell that we are trying to minimize or maximize? And what is that? What's our objective in this case? Yeah, we want to minimize what? Yeah, minimize the risk. And so we'll change this to minimize, and then we'll set the target as a single cell. You only get to do one cell that you could say, make this most or least. And so I'm going to come down to standard deviation. I want to minimize the standard deviation. Since the variance is just the square root of the standard deviation, you can minimize that too. Either one of those work as well. Now, what cells then are we allowed to change? And so in this case, we're saying, Solver, you're allowed to change all these weights. Let's select that whole range of weights. That's the cells we're allowed to change. But it has to be subject to some constraints. So we've got to add the constraints in. So subject to the constraints, I'm going to come over here and add a constraint. First constraint is that right here, G7, our sum of weights, that has to exactly equal 1. If I say OK, it'll take me back and I can add another constraint, but it knows you might want to add a bunch of constraints all at once, and so you click Add, and we're ready to put in the next constraint. What's another constraint that we have?
Expected return.
Yes. It's kind of spelled out right here, is that this right here, the expected return from this portfolio, has to be greater than or equal to, change that to greater than or equal to, and then this required return that we have here. Notice something here, it didn't just put in F10, it put in equals F10. That'll be interesting to us here in just a minute. Let's see, are there any other constraints?
We need to tell that the stock can't be negative.
Yeah, but you know what? We'll do that with a setting. It kind of does make sense to say, negative. That would be like, what's it called? Shorting the stock. But we're just going to say, what are we going to? We're not getting that. I have a hard time just understanding this model the way it is. So, no negative numbers here. But we'll do that with a setting. I think that's the only constraints we have to plug in. Oh, and right here, the check marks right here, make unconstrained variables non-negative. So I think that's the non-negative part. Then we have different models. The truth is, I don't know the difference in all these models. Nonlinear, simplex. I'm just going to go with the default. I think any of them would work for this particular one. And then we just say solve. Well, thank goodness, solver found a solution. All constraints are, and optimality conditions are satisfied. Great. Keep the solution, say OK. And then, yeah, we got up there. And what was our, at this particular standard deviation? The truth was, I wasn't paying attention to what it was before. So did we even get lower than we were? Yes. Okay, so drove it down. So when we turned the solver loose on it, it was able to increase the expected return and decrease the risk. It's better than I am at this. The truth is, it did that by guessing and checking tens of thousands, maybe hundreds of thousands of values to be able to figure out just right where the sweet spot was. Now here's the thing about solver. Solver is dependent. We could tell this solver just to run itself again. Now that it's configured, we can say run this solver. We could change some parameters here and run the solver and run the solver and run the solver again. That would work. But if in between runs, what we have to do is change anything about this. If we have to change how many cells that we're allowed to modify, then that's going to be a much more involved thing. So we're going to have to code the solver to be able to behave the way we want it to behave. And so in this case, the whole idea behind this model is that we want to be able to say, no, we don't want these 10 stocks, we want these 14. Let's add some stocks in here and see what we can do with it now. And in fact, we might want to write something that says, well, you know, what would happen if we some kind of loop that's saying, well, try it with these 14 and then narrow it down to these and other things that we just want to solve each time and kind of keep track of them. Or we might want to say, you know what I'd like to do is I'd like to change what my required return is. You know, what if my required return was only 1%? What would it look like? In fact, I might want to build an efficiency frontier, right? I want to plot out, you know, what level of risk do I have to achieve, or do I have to accept to be able to achieve a certain return? There's a curve that I can't do better than along that curve. We'd like to be able to see that. In fact, with any luck, we'll produce that curve today in class. Okay, so that's the process. Are you ready to actually do it with code? Let's do it. So I'm right here, this all looks pretty good. I'm going to go ahead and reset these back to 0.1 across before I record. And then I'm going to record myself doing that same process that we just did by hand. Yeah, that's right, we're at 0.06, and we were solved at 0.05, so we got another 0.5% out of this thing with reducing our risk. That's great. Okay, so turn on my recorder. I'm not sure I pointed this out to you, but you got a little record button in the bottom left-hand corner. It's always there, just waiting to be clicked. Macro2 is a fine name for it, because we're going to use it to get the code that we need, and then we'll copy that code out and put it where we want to. Okay, I'm just going to go through that process. So on the Data tab, I'm going to choose Solver. I'm going to start by resetting everything. Turns out, if I just added the constraints here, each time I ran it would be adding new constraints. So I want to start off by saying, let's blow away everything that's here. So we're starting off with a clean reset each time. Objective cell is a standard deviation, and we're going to minimize it by changing the weights. We're going to add a couple of constraints. So sum of weights has to be equal to 1. Add that constraint. Our expected return has to be greater than or equal to our required return. Say OK. And I think that's it. The rest of this should be OK. I'm going to say solve. Should solve it again. It found a condition. So say OK and stop recording. Let's go take a look at the code. Before we look at this code, though, how many of you ever felt, you know, when I was doing this code that the macro recorder generated, I think it's a little bit weird. They could have done this a different way. Just the language itself, it could have been different. Should have been different, might have been better. Yeah, I think that's most of us. That's all stuff that was written by Microsoft. This add-in, including the macro recorder, not written by Microsoft. It's written by another company called Frontline Systems. If you thought Microsoft had problems, get ready, because frontline systems do some really weird things. But we can work with it. I don't know how much Microsoft pays frontline systems to distribute their software. Maybe nothing. Any of you do a lot with optimization? Here? The whole idea for frontline is that, Solver will get you to do a lot of things, but if you get really serious about optimization, you're going to go buy a different add-in from frontline to do real heavy-duty optimization. And how much is that going to cost? Yeah, will it be more than Excel? Oh yeah, way more than Excel. I'm not sure they have one that sells for $10,000, but it might. You may have some pretty expensive. I know I looked at one once, and this add-in was $3,000. There's something wrong about paying more for an add-in than you pay for the whole program that runs it. My opinion, but I guess they're making money. All right, let's go look at the code. Macro 1, solver reset. Doesn't look terrible.
Was there macro 2?
Is it macro 2? Oh, this could be my other work. This could be what I recorded last time around. Let's close all of it.
Module 3.
So, thank you. Let's look at module 3. Macro 2 and module 3. Thank you. Yeah, pretty similar to what we had there before. I'm going to delete these comments here. Okay, first one, not so bad. Solver reset. Can you guess what it does? Resets the solver. Now, this one, a little bit weird. The name of it's strange. Solver OK. Set cell D14. What's this? Our target cell. Yeah, that's what we're trying to minimize or maximize. Max min val is 2. What does that mean? Minimize. Yeah. What's maximize? I don't know. Recorded. Probably. Value of we didn't even talk about. But if I come back here and just take a peek at solver, I don't have to minimize or maximize. I can try to get as close to a particular value as possible, and that's what that would be. So it's just not necessary because we're not using the going to particular value. By changing then, it's plugged in this range for us. And the truth is, I have named that range weights. And we could plug in weights in there. It's just something to identify the range. So we could plug in weights there. Since we're not going to be changing this model, we could leave it that way as well. But we might need to have some code here that looks at how it's configured and says, where do the weights start, where do the weights end, and plug in that particular value. I'm just going to change this to weights. It's just an identifier for the range that we're changing. The code that generates this to where we have sets that range to be that specified set. Put here engine, and it's nonlinear. So that part looks pretty good. Solver add. G7, relation is 2, that's probably equals, and our formula text here is 1. That's going to give us a problem. We'll talk about that after we see the problem. Let's go ahead and go through the rest of this first. We have another solver add. Oh, this time I actually used the name to cell, the name of the range, the name of the cell. So we are setting our expected return to be greater than or equal to the required return. And now we have another solver OK. What is this solver OK? Is it any different than the one we have above? Well, that's because I changed the one above. But it's the same. Why is it here? I don't know why it gets recorded. It's totally unnecessary. Delete it. Oh, we got another solver OK. Is there anything different here? Have we changed anything? No, it's the same thing. Delete it. So now the code doesn't look too bad. Reset the solver, configure our target and such, add a couple of constraints, solve the solver, we're in good shape. You ready to run it? Step 1, you've got to make sure that you are on the sheet. There is no way for the solver to solve Could I have more than one optimization configured on this workbook? Yeah. Potentially I can have one per sheet. I can't have more than one on a sheet, I can have one per sheet. We're used to saying, you know what, I want to refer to a different sheet and solve that solver on a different sheet without it being active. No. The solver that you're going to solve has to be active. So make sure that that's active, and let's go ahead and run that code. Oh, let me go ahead and change this so we can see that it works. 0.1. And I'll go run that code. Keep solution, that sounds great. We'll say okay. Looks pretty good. Holy cow. Portfolio variance. Oh no, there we are. That looks great. 0.4. Even better than it did before. How could that be better than it was before?
Sum of weights is not 1.
Sum of weights isn't 1. Oh no. I told you there was a problem with that one. What could the problem possibly be? Here's a little quirk. I don't know why this is. It works just fine when I put 1 in there in the solver and run it. But in this code, you see how this says formula text? This has to be a formula. How do I write a formula that equals 1? It equals 1 plus 0 equals 0.5 plus 0.5. I mean, something in there. Or just equals 1. It's got to be a formula. That seems like it's kind of a strange little quirk. That's why you're coming to class, to learn the strange little quirks. I'm going to solve it again. Okay. And now it has respected that particular constraint. And the rest of the constraints here are met well. Okay, so there's that problem. Questions? In the back.
Even after I changed equals 1,
yep.
I ran it again, and my sum of weights is just a little bit over 1. Like it's 1.6 zeros. And then
yeah. So in that case, well, the question is, I've got 1.000000000000001, and that's just kind of the way the solver works. So the solver is working with on a particular threshold, and 6 places past the decimals beyond the threshold that you have set. So you can play with that by somewhere in the options, constraint precision. Something around here you could probably change it so it would go further, but that's the nature of solver. It's always kind of approximating, and so it's looking at your 1 that has a bunch of zeros and a 6 after it, and it's going that's close enough. Okay, let's go ahead and integrate this into the existing code. Let's take a look at the code that we had built for this whole application. So for that, I'm going to come back to module 1. And so the build model button just runs a bunch of other sub-procedures. And this is kind of a common way to organize a program. To say, listen, I got different steps I have to go through. Let's set those up as different procedures, and then we'll have the mother of all sub-procedures. We have one sub-procedure to rule them all. And that's what this does. So it just says, call these other sub-procedures in this order. And so the rest of these is pulling the data in. It's doing the summarization. It's doing the aggregation. It's building the model sheet. And in fact, all of these sheets get generated. Build sheets, build new sheets. If we look for build new sheets, we can see that we're actually adding these sheets. We're going to add a sheet. We're going to call it Yahoo. We're going to add all these sheets. We're going to configure some information onto these sheets and so forth. So the existing code gets us all set up. You'll notice then that we have config solver. Config solver right now is blank. And so let's go ahead and pull the code in from module 3. In fact, I may just go ahead and pull all of this code in. It doesn't all belong there, but at least I'm going to get it into this module so that we can work with it a little bit more easily. So I'll come back to module 1, and I will just plug that into config solver. So let's just think, does this make sense to reset the solver? Whenever we go to configure the solver, does it make sense to start off by resetting it? Yeah, it does. We're going to be added constraints. Let's make sure that we're turning those off. So we are plugging in all of these. That looks pretty good. We probably don't want to be solving the solver here. And so I'm going to pull that off and put it under run solver. Now, here's the thing. If I'm going to be manipulating the solver model, there might be 4 solver models in this book. How does VBA know which one I'm talking about? This is a general solver reset. I've got 4 of them. How does it know which one to reset? Whichever is the active work sheet. And so, which one is it? Model is the one. So I better come in here and say sheets, one called model, not activate. And in fact, I better do that also before I go to solve, before I say to solve the solver model. So for both run solver and config solver, anytime I call these, I just want to make sure I've got the right sheet activated. I don't know what else somebody might have done. Let's make sure we get the right sheet activated. Okay, let's just go ahead and see. Yeah, we can't really run the whole thing because this first part doesn't work anymore. Should be able to run config solver, and then should be able to run solver. Oh, that brings us to some strange thing here. When we run this, what does it do? Prompts the user. Hey, good news! We found a solution. You want to save it? You know, ultimately, where we're headed with this, where we're headed with this is we want to say, don't just look at this mean on return. We would like to look at the very lowest expected return all the way up to the very highest expected return, kind of in even increments. We want to run this model multiple times and be able to build a chart. And it says, what's the possibility with this portfolio? And if I had to run that 20 times, the user's going to have to clear that 20 times. Yikes. Let's take a look at what we have to do to turn that off. Right here on solver solve, I'll hit space. There's a parameter. Doesn't get recorded. There's a parameter. Solver solve, I get user finish. That means if you put true on this, it means your user speaks finish. And we'll put the results in the finish language. That's a joke. Thank you. And one person laughed. It's a Boolean variable, true or false. What do you think it does?
True.
If you put true in there, what does that mean? User finish equals true. What behavior is that going to do?
The user has to finish the model.
The user has to finish it. So false would be the user doesn't have to finish it. So we want to put false. Let's give that a shot. That didn't do it. Still coming up with the okay. So let's just try the opposite.
Put it in parentheses.
Nope. That would work. It's like exactly backwards from how you would expect it to be. But that's what it is. It's Boolean. Called user finish. True means the user doesn't finish it. False means the user does finish it. The other parameter here, incidentally, is there's like some other report that the solver can generate. There's a checkbox that you can tell to generate this report. And if you have that one, it should generate another sheet. Maybe not. Yeah, pay no attention. I don't know what that other parameter is. All right. So now, if we look at the Find Frontier, which is already built, all Find Frontier does is it's going to change the value that we have in our required return here. The expected return is calculated from the weights and the means. So it's going to change what we have in the required return, and it's going to run the solver multiple times and then plot that. So now that I've got this kind of configured up and running, let's go ahead and run Find Frontier. Hopefully it works. And it should make changes, solve, make changes, solve, make changes, solve, build a table with the results, and then plot those results. So what it's done here is, remember, for each configuration of the model, we have some risk, the standard deviation, and we have the required return, the expected return from that particular, or let's see. We have the required return and the risk. These are the weights that produce it. So you'll notice that as I'm moving my required return from something low to something higher, I should be having to accept more risk as I go. And you can see that's happening. And so these are the portfolios that Solver produced. It said, listen, under no circumstances should you purchase Microsoft or GE or American Express? Why?
Their return is
No.
not
Based on the way that they behave, you're not going to be able to get your risk down anymore by adding those in. So we've got stocks that are less risky that have higher returns. You would never put those in your portfolio. That's what it's saying. That's kind of interesting. We kind of see some, some start off at the beginning down here. Don't put Apple. Why not put Apple? Why do we start off saying Apple's a bad thing? Yeah, too much risk.
Bad apple.
It's a bad apple. Got about as many laughs as mine, so don't feel bad. And so then this is just a plot of this data right here. It's just an XY scatter plot of this data. Let's see, which one's the required return? So we're getting up here to 0.025. So the required return is here, the risk is here, and we're saying you can with this portfolio, you can be anywhere to the right of this curve. You can take on more risk for a given amount of expected return, but there's no way to configure this portfolio to get you out here into this thing. And so it's kind of a nice example of optimizing the solver. All Frontier does is it says, start with the lowest return and move by 10% increments up through the highest return, solve and plot. Questions on automating solver? Questions on anything? Purpose of life? Final exam at the testing center, by the way. Yeah.